Okay, we're finally there. Fire away.
There we go. Okay, I thank everybody for calling in today and listening to us give our presentation of our BetaGuard PM particulate monitor for the Portland Cement MACT. If you'll go to the next slide, Bob. Just want to hit a couple of points on the monitor. There's a couple of pictures on the right-hand side of your screen. If you look at the top monitor, in that installation, you can see we had a data logger installed as part of the project to handle the data interface between the instrument and the data acquisition system. Just to the right side of the data logger, you can see the black heated sample line bringing the sample into the instrument. Just beside that, there's a dry gas meter provided for the monitor, and that's used for doing the quarterly sample volume audits that is required by the Performance Specification 11 for particulate monitoring. And then just to the right of that, you can see 3 rotometers and some regulators and coalescing filters. That's our air control system for controlling the air to the ductor and the air pressure for the blowbacks. The picture below that shows the front door of the instrument open. In the upper right-hand side of that instrument is the display. That's where the user interfaces with the monitor through various screens and sub-menus. Then there are a series of switches that turns the instrument into run and standby. The operator can put the instrument in maintenance right from the instrument. Beside the switches, you see some pressure and vacuum digital readout gauges. Just below that top swing panel there in the center is the beta gauge portion of the BetaGuard PM. Our instrument has 2 beta gauges, a left and a right. Just below that, you see the spool of filter tape. That's where we collect the particulate samples for measurement of mass. And then right below the spools of filter tape is the PLC, which controls all the operation of the instrument. The BetaGuard offers the industry a direct measure of mass concentration, and we'll talk a little bit more detail about that in the next slide. We designed the BetaGuard to replicate EPA test methods for particulate, and we do everything possible to replicate with our sampling temperatures and things like that so that we're getting the exact same particulate that the stack testers measure when they come out to your plant and do a compliance test. We use NIST traceable mass standards to calibrate the monitor's internal mass measurement using those beta gauges. One of the advantages of beta attenuation mass measurement is that it's independent of particle characteristics. So the accuracy of the mass measurement reading is not affected by changes in particle size, color, density, and things like that. With our instrument, we use dilution sampling technology, and that makes the instrument work very effectively on a wet scrubber stack, and we've got multiple installations on wet scrubber stacks in the U.S. The instrument also uses isokinetic sampling for extracting the sample gas out of the stack, which is a requirement of PS11, and we'll talk a little bit more detail about that in a few slides. The instrument does automatic daily mass and flow drift checks as required by the performance specification, and we're seeing very good long-term unattended operation of the instrument. It's not a high-maintenance sampling system or instrumentation, and we're getting fairly high data availability. All of our installations are getting greater than 90% data availability. Next slide, Bob. I mentioned that the first bullet item is the BetaGuard is a direct measure of mass concentration, and we tested the instrument with against a NIST particle concentration generator. We compared the BetaGuard concentration readings to the concentration generated by the NIST device, and we did about 28 test runs over 4 days over a range of concentrations generated by the NIST device from about 2 to about 34 milligrams per cubic meter. And when you plotted up that data and you compared the two and did a correlation, we got almost a 1-to-1 correlation with a very strong R-squared. So that's what it means that the BetaGuard gives you a direct mass measurement of particulate concentration. Next slide. This is a picture of the NIST mass standards. These are what we use to generate the internal mass calibration of the beta gauges, and then a set of these mass standards is provided with each instrument, and we use these mass standards for doing the quarterly mass audit that's required by PS11. So I just wanted you to see the standards that we use for calibrating those beta gauges. Next slide, Bob. I mentioned that the beta gauging is independent of particle characteristics, and what I'm showing you here are 4 pictures of the various types of particles that we collect at the different installations that we have around the country. Some of the sources generate a white particulate, as you can see in the upper left-hand picture. All the spots come out nice and white. If you look at the upper right-hand picture, that source is generating all gray particles. Some of them change color a little bit, as you can see from that slide. If you look in the lower left-hand picture, in that source, most of the spots are white, but the second spot in, you can see is gray. And each one of those samples, those spots is a 10-minute sample of particulate out of the stack, and all of a sudden the particulate changed color. I happened to be there to snap that picture when that happened, and I got on the phone real quick and called the control room and asked them if they had done anything differently, and they said no, they hadn't, but certainly the particulate had changed color, and it happens very quickly, and we see this all over the country at our installations. The particulate does not remain constant all the time. And then if you look at the lower right-hand picture, those spots are all dark gray. We typically see that on coal-fired combustion, although the spot that's going over the roller there on the right-hand side is a much lighter gray than all the other samples. So I just wanted you to see the different types of particulate that come out of various sources. Next slide, Bob. PS11 is the performance specification for particulate monitors, and there are quite a few requirements. It's a very detailed performance specification. In the beginning sections of PS11, it's where it tells you, the source owner, what type of instrumentation you're supposed to select, and it's kind of open. It says that you, the source owner, are supposed to select a continuous particulate monitoring system that's appropriate for your source. That leaves a lot open for interpretation. There's a lot of wet stacks. There's a lot of dry stacks. There's processes that use blending of various fuels. So you really have to be careful when you're selecting a particulate monitoring system that it is appropriate for your source. The BetaGuard works in wet and dry stacks. The BetaGuard, as I mentioned, its measurement is not biased by changes in fuel supply, process operation, the stack gas flow, moisture, or temperature. So the BetaGuard is appropriate for all cement plant sources required to monitor particulate. PS11 says that the source owner is supposed to monitor particulate at a location that's representative of particulate emissions as measured by the reference method, method 5. We can vary the BetaGuard probe length as needed to find the representative sampling location in your stack. and we can actually perform a particulate characterization test in your stack to find that representative sampling location. We've done that many times at stacks. Next slide, Bob. PS11 tells us that if you have an extractive continuous particulate monitoring system, which our BetaGuard is, that you must maintain an isokinetic sampling rate. The BetaGuard samples at 100% isokinetic, so we meet that requirement. PS11 says that you're supposed to install your continuous particulate monitoring system and determine what type of process changes affect particulate emissions. And that's so that you can set up your correlation test plan and get the different particulate concentrations that are needed. We work with your operations personnel to set up those operating procedures for the PS11 correlation test. So in all of our installations, we'll come out to your site, sit down with you and the monitoring data and take a look at what fuel blends created higher particulate, what fuel blends created lower particulate, what process operating procedures were you doing when we saw higher or lower particulate, so that we can generate and develop an effective test program for that PS11 correlation test. And then we enter the certification process, and it's simply a 7-day drift test and a correlation test. And MSI can bring a test team out to conduct that correlation testing for you. Next, Bob. Just a little bit of information about the PS11 correlation test. If you've been a person that's been following particulate monitoring, you've heard about this test, and you might have heard some nightmares about the test. It's not that challenging. We've done it many times and have been successful in all of ours. But the correlation test requires that you collect 15 data points over a wide range of particulate concentrations. Specifically, there are 3 particulate levels that are identified, and you need to get at least 20% of your data points in each of the PM levels, which basically tells you that you need 3 data points in the low particulate level, at least 3 data points in the mid particulate level, and at least 3 data points in the high particulate level. Obtaining those different particulate concentrations is a challenge, but it's not impossible. As I mentioned, we've done it many, many times. You, the plant owner, we can use different flow rates, different production rates, different fuel blends. In the cement industry, we can look at testing with the raw mill on or the raw mill off if you have that at your plant. We can detune the primary PM control equipment to generate different particulate levels. And for the beta gauge monitor, we can actually pull the probe out of the stack and sample ambient air to get our 0 point. And you can only do that with a direct mass measuring device like the beta gauge. You would not be able to do that with an indirect mass measuring device like a light scatter or a triboelectric or something like that. And then once you collect all your data, you calculate the correlation between the monitor and the reference method, and from that correlation, you determine 3 statistical values: the confidence coefficient, the confidence interval, and the tolerance interval from that correlation, and you compare that to the PS11 criteria to make sure that your monitor meets that criteria. The next slide here is Bob showing is an example of one of our correlation tests, and you can see the 3 groupings of data, the data that we had down at the 0 level, the data that we had at the mid concentration, and then the data we had at the high concentration. And we showed the confidence coefficient, 0.988, has to be greater than 0.85. The confidence interval is 0.79 in this example. That has to be less than 10%. And the tolerance interval in this example was 2.7%, and that has to be less than 25%. So this installation met all of the PS11 requirements. Next slide. And this is just another installation. You can see the groupings of the particulate that we generated. We got data down near the 0 by pulling the probe out of the stack. We had our second grouping right there around 20 milligrams reading on the BetaGuard. That was normal operation. And then we perturbed the system, detuned the control device, changed the air-fuel ratio at this facility, and generated those 5 higher data points for our high level. And again, showing the correlation statistics there, all of them were well within the PS11 requirements. Next one, Bob. So we just wanted to discuss some of the advantages and benefits of the BetaGuard. As I mentioned, it's a direct measure of mass concentration. The BetaGuard does not experience inaccuracies when particles change. This gives the source owners complete fuel and plant operational flexibility. We've taken a look at some of the fuel blends that cement plants use, and some of the cement industry uses probably the most varied fuel blend that we've ever seen. One of the kilns we looked at burns natural gas, coal, petcoke, tire-derived fuel, used oil, and wood chips. Another kiln burns coal, natural gas, tire-derived fuel, used oil, petcoke, oil absorbent, and spent activated carbon. Another one adds plastics to that mix, and some of the kilns are now starting to add biomass to the fuel mix. This is a very challenging, this is going to create a very challenging flue gas stream, and the particulate is going to vary quite a bit depending on what the fuel blend is with that much variation in the fuel. What we can say is that the BetaGuard will not need multiple correlations for those various fuel blends, which is a good thing for the plants. The particulate concentration from the BetaGuard is in standard units. The BetaGuard outputs milligrams per wet standard cubic meter and milligrams per dry standard cubic meter, allowing us to calculate the emission rate from the stack in the units of the emission standard for the PC MACT, which is pounds per ton of clinker. There's no need for temperature, pressure, or moisture correction monitors because we do output in standard units. And also, we would use the milligram per dry standard cubic meter output for startup and shutdown. The MACT standard changes the emission limit for startup and shutdown to a straight concentration value instead of pounds per ton of clinker. So you would not need any other pressure correction, moisture correction, temperature correction to the BetaGuard to get the emission limit for startup and shutdown. Next one. The BetaGuard measures real particulate concentration, as I said, in milligrams per wet standard cubic meter, similar to a stack test, not a surrogate like light scatter intensity. The BetaGuard measurement is insensitive to changes in control equipment operation and plant operations, which allows the plant to do whatever pollution control they need. If dry sorbent injection, if the dry sorbent injection rate changes over time, that will not affect the correlation of the BetaGuard or its measurement accuracy. And again, it does not need multiple PS11 correlations depending on how the process changes. Next one. As I mentioned earlier, the BetaGuard does sample isokinetically. That means that it extracts particulate at the same concentration that exists in the stack. Isokinetic sampling is the only means to extract a representative sample out of the flowing flue gas stream. Because it does isokinetic sampling, there's no bias in the measurement when the stack gas velocity changes, and there's no additional testing to prove acceptability. If an extractive sampling system does not extract gas at 100% isokinetic, the source owner would have to do additional testing to prove that the bias is not great in their stack and that the non-isokinetic sampling would be acceptable. With the BetaGuard sampling isokinetically, there's no additional testing needed. Next one. As I mentioned earlier, you have to find a representative sampling location in the stack, and that can vary from stack to stack. The BetaGuard probe length is adjustable and can be positioned as dictated by a characterization test if you so choose to do one of those. We have probe lengths that vary from 24 inches to 15 feet. So we can build them, the probes, to whatever length is needed for a specific stack installation. Another advantage of the BetaGuard is that it can be located remote from the probe up to about 150 feet. We have two installations that are at about 165 feet. So some of the installations in the cement industry, we would be able to install the monitor at the SIM shelter at ground level. This means that for doing quarterly audits and things like that, no one would have to climb the stack, and that's a pretty important point. Next. So to sum up our presentation, the BetaGuard is reliable, accurate, simple to operate, and easy to maintain. The BetaGuard truly meets all the requirements of PS11. The BetaGuard has wide operational flexibility, which allows us to optimize the setup for site-specific installations. That's pretty important. We do that at every facility, trying to optimize the sample volume, reduce the sample time as much as possible so that we get more samples per hour. The BetaGuard is a direct measure of particulate concentration, as we mentioned. MSI can provide all the services that are required. If you would need us to do the testing for the PS11 correlation, we can do that. If you would like us to interface to your SIMS data acquisition system, we can do that. We can modify your QA/QC plan for your CEM system to incorporate the BetaGuard particulate monitor, so there's really no need for outside consultants. MSI has extensive experience with particulate monitoring in the United States. The BetaGuard has over 1 million operating hours at installations in the United States, so we can help ensure a successful particulate monitoring program at your cement plant. And that concludes the presentation.
Good. We'll take questions from the floor here as soon as we get back and unmute everybody. So we'll unmute all here. And we're ready to go with questions for Craig.
Hi, Craig. This is Tim Downey. You indicated that the BetaGuard does not have to be recalibrated or correlated when the fuel mix changes substantially. For example, by adding different types of biomass. This seems like a tremendous advantage, but I'm not sure I understand why. Can you elaborate on that more?
Yes, the BetaGuard it just measures mass. So whatever we put on the filter tape is what gets measured for mass. And beta gauging has been around for 60 years. It's a well-documented method of measuring mass. So what we do is with those mass filters, we generate that internal mass calibration, and then we go out and correlate it to your particulate. And what we've seen is that that correlation holds regardless of what the particulate concentration or the particulate material is.
Okay, so what you're saying is the instrument doesn't care what the particulate size, shape, makeup, chemical composition, or anything is, correct?
That's correct. We don't care what it is, if it's calcium-based, silicon-based, carbon-based. those particles absorb beta and attenuate the signal strength, and that's what we look at is the reduction in beta strength from the clean filter tape to the dirty filter tape.
Okay, thanks.
You're welcome.
Yeah, I think that's an important point. Other questions? One thing that could be important is the fact that by measuring after the scrubber, you're frequently measuring considerably lower particulate levels than if you were to measure prior to the scrubber. Is that not correct?
Bob, that's what we see. We're seeing anywhere from 60 to 95% particulate reduction across the scrubber. You can look at, if you have a facility that installed a new scrubber and you look at pre-scrubber particulate data compared to post-scrubber particulate data, that's one way to look at the additional reduction. And we've had a few facilities that have done upstream and MACT particulate testing across the scrubber, and they're documenting, like I say, anywhere from 60 to 95% particulate reduction by that scrubber.
Well, that's certainly very important information because you know, you've and let me show my ignorance. I haven't asked the question before, but would you be allowed, you know, with any of these light scattering devices to try to justify having met the PM standard by measuring before the scrubber rather than after it? I mean, obviously, you know, opacity monitors are doing that, and it's ridiculous because, you know, you're measuring in the middle of the process. But now we've got a new PM mass monitor standard, and I guess the question is the same flexibility? Yeah, you can measure it before the scrubber, you know, after the particulate device, because that's where you don't have any water vapor.
Well, I don't think you'd want to measure before the scrubber to meet your particulate limit. And there are extractive light scatter monitors for wet scrubber applications.
So I think, so basically my question is that there won't be any of these cement installations or utility installations that are now required to put in the PM monitors that will try to measure anywhere except at the stack, right? I mean, they're not going to be able to do it like the opacity monitors where they measure, you know, prior to the scrubber.
Correct. I think all of the particulate monitoring will be done in the stack.
Thank you for clarifying that. Well, it's a very, you know, just the fact that you have so much experience, you have experience in cement, I'm sure is of great interest to our attendees today. Any last questions before we move on?
Well, thank you very much.
Yeah, Craig, very well presented. Thanks.